presentation is from Elvis Gerardo Ortega Ochoa from the Open University of Catalonia. The title of the talk is Pedagogical Conversational Agent for Tutoring in the Development of Educational Research Projects. Okay, I just put Elvis on stage. Okay, you are on stage, you can share your presentation, Elvis. Thank you.
Thank you very much. Okay, I will share my screen. Okay, correct. Dear all, today I am going to share with you a research report about a pedagogical conversational agent for tutoring in the development of educational research project. You can see the structure of the conference on the screen. Let's start. About the introduction, the average student-teacher ratio in vocational training programs is 13:1. In this context, some countries struggle to provide a personalized response to a growing student base. As a result, there is a need to adapt the educational process to the student characteristics. However, in the last decade, emerging technologies and practice have been addressing this situation through adaptive learning. It is the case of pedagogical conversational agent, PCAs, with high interaction with the student. Therefore, the research topic is the algorithm of the PCA dialogue system. In this context, in Ecuador, the National University of Education, UNAE, for its acronym in Spanish, initiated at the end of 2017, among other careers, the basic education career, distant learning for teaching professionalization. Based on the teaching practice, in each professional training cycle is developed an educational research project called Knowledge Integration Project, PIENSA for its acronym in Spanish. In this project, tutoring is provided to help, support, and accompany the training process. The situation has several approaches. On the one hand, although there has been advancement in adaptive learning, especially related to the algorithm or the PCA dialogue system link the different domains, for instance, mathematics, programming, physics, and computer science, and so forth, there is a research lag between the connection of this system with tutoring of educational research projects, as well as a comprehensive approach to the study object through the mixed method. On the other hand, considering that tutorial accompanying is a process direct and personalized to each PIENSA in theoretical, methodological, and practical aspects of the research project, the dialogue mediated by information and communication technologies must activate the teaching and learning process. As a result, there is a problem based on research and practice. From deductive reason, the algorithm of the PCA dialogue system for tutoring, the PIENSA is a variable which corresponds to a categorical type because it allows characteristics in the algorithm according to the participants. Thus, the research question is, what is the algorithm of the PCA dialogue system for tutoring the PIENSA based on the student preference? The question has a descriptive orientation and requires the consideration that the particularities, characteristics, and needs of the university students. About the review of relevant scholarship, project tutoring is a guiding activity that must be highly personalized. However, the student-teacher ratio does not facilitate this activity. Nowadays, educational technology, specifically the PCAs, allow attention to this situation through adaptive learning. The first word in the case of intention and entities, the first word refers to a dialogue topic, and the second is then relevant to a specific and personalized context for the intention. The PCA algorithm refers to the set of instructions established, organized, and circumscribed in the case for tutoring the educational research project. Consequently, some studies have determined the characteristics of the algorithm of the PCA dialogue system. In first step, Tamayo doctoral thesis propose a type of design integration of evaluation methodology, MEDIE for its acronym in Spanish, of the PCA that consider preference so that any teacher can use in his or his classes. The methodology has phases that emphasize the algorithm characteristics, role, general, and specific functions. Through quantitative response design from the perspective of the educational actor, user-centered design. In the practical session, one of the main results was to achieve the PCA use in the classroom. In addition, the teaching staff has been able to adapt the course characteristics with relevant content for the student. Also, the second research adapt the PCA to the student and their emotion, try to have a natural dialogue. The PCA mimic the conversational movements of human tutor-teacher, as well as pedagogical methods for physics and computer science students. Mainly, the research construct an expectation and misconception tailored dialogue EMT, which is based on the conjunction of semantic patterns and attempt to finalize the pattern using recommendation and announcement. Future EMT create reasonably fluent dialogue in auto-tutor and prompt the learner to learn. And the last, Ocaña et al. Research established PCA conversational management guidelines for teaching programming based on the conversational particularities. The media was used in the drafting process and assessment. The study analyzed 66 children conversation and dialogue simulation about what they would like to learn in programming, which allowed them to know the dialogue system. Content analysis categories were course, text type, dialogue topic, number of question and exclamation, dialogue length, knowledge level, and friendship intention. Thus, the analysis facilitates the suggestion generation of the PCA design linked the programming teaching. All in all, the review demonstrates that there is no research on the algorithm or the PCA dialogue whose domain is specifically tutoring in the developed educational research project. Despite this, the study present are the research-based because they consider transversal elements, for example, theoretical, methodological, etc. These are processed for the PCA co-design and it's linked with the domain, dimension of the dialogue system, and instrument to determine the student preference. The study objective, in this case, the research is initial, saying the study is, the objective is determine the algorithm or the PCA dialogue system for tutoring in the basic education career distance learning at the UNAE academic period semester 1, 2021. Considering that purpose exposed two realities, objective and subjective, established by the interpretation for each student. The study has a mixed method which uses the survey to collect data from a pragmatic view because the dimension of the algorithm of the PCA dialogue system requires it. The research applied pragmatism. Creswell and Plano-Clark indicate that this paradigm highlights the application value. What work, what solve, and provide response to questions from a mixed method. That is, pragmatism promotes an integrative approach to resolve traditional philosophical dualisms, as well as to make methodological decisions. Then, the reason for selecting this paradigm was that the study required in-depth research, which required a quantitative and qualitative approach. The limitation of a qualitative or qualitative research approach is not relevant in the paradigm since it will be pertinent to integrate all paths to respond to the study purpose. The reason for using mixed method research was the need to obtain complete and corroborate results. The study was descriptive scope, cross-sectional and empirical, and apply a convergent design and use the questionnaire variant called mixed method LI to respond to the research purpose. Design implies collecting and analyzing quantitative, mostly, and qualitative data simultaneously. In both approaches, the algorithm of the PCA dialogue system was determined. The population was the student of the professional training unit of the basic education career, distance learning at the UNITE, academic period semester 1, M equals 1,124. The student fulfilled the role of apprentices and they are teachers in each of their schools. Furthermore, their knowledge and skill are very enriching since they have had different formative contexts. The population sample was identical for the two approaches. It was selected with a one-stage cluster sampling technique since units of analysis were grouped in courses. A cluster was equals 36. In this regard, the risk assumed was the student in the different cluster would also have different characteristics. The sample with a 95% confidence level and an estimated sampling error of 5% was 287 students. It is worth mentioning that the sample was increased by 10% to allow freedom in particular case. They were mostly in the age of 30 to 39 years. The simple random sampling was applied to select cluster and participants. Moreover, a pilot test was applied to 100 of the 360 participants. After determining the sample size of each cluster, the participants also were selecting use SRS. The instrument was the questionnaire, which allowed data collection. The study adopted and unified the questionnaire proposed by Tamayo and Ocaña. Accordingly, tool consolidation had three stages: adjustment, pilot test, and final version. The final version has three sections: role, general, and specific function about the PCA. Each of the first two sections has one closed question, and the third has closed question and one open-end question. The scale of the closed response is nominal and interval, 5-point Likert scale. On the other hand, the open-end question requires further categorization for content analysis. In addition, each of the question and response is defined by a data coding scheme, identify the different response alternatives and treatment of missing values. The research procedure had the first mediate phase, that is, I conduct the student survey. The survey was voluntary and the questionnaire was administered electronically in Microsoft Forms. Participants receive information in the mails at the UNITE institutional server to ensure correct reception in the inbox. Mailing lists correspond to institution database. Therefore, the quality was optimal. The student received specific and homogeneous instruction in the pilot test and final version. The process began with a first email containing the survey information. Subsequently, around halfway through the stipulated line, a follow-up email was sent to each participant who had not completed, accompanied by a message and a telephone call. Finally, 12 hours before the completion, a reminder was sent by email. Regarding the monitoring strategy, the participants were accompanied synchronously and asynchronously during the process through the mail, phone call, and chat group to determine the process. Give any help or clarification and achieve a high response rate. In this context, communication is not considered instructive because they are using to constant dialogue with a teacher-tutor. About data analysis, meta-inference were obtained through the horizontal mixed analysis of the quantitative and qualitative data collected. It involved a mono-analysis of qualitative data and a mono-analysis of qualitative data. Nevertheless, these results did not interact with each other in any way until the data interpretation phase. Data analysis and interpretation were developed using descriptive statistics and content analysis. The first technique allowed the data systematization in indicators and charts of the nominal scales and interval question, and the second favored the text inference of the open-end question. The quantitative and qualitative analysis were performed using IBM SPSS statistics and in vivo respectively. As for the instrument evaluation, I exposed the validity and determined its reliability. First, instrument validity was based on positive consequence obtained in its application, in this case, Tamayo and Ocaña. Secondly, instrument reliability was determined in the pilot test applied from November 12 to November 15, 2021 to identify unclear or confusing instruction and question. The results indicate that the participants agree with the instruction clarity in the process, the question clarity in the questionnaire, and agree in that there were no problems in understanding the question type or in responding to them as they have been approached. Also, the student comments are positive. Also, a financial reward was given to encourage the student participation in the final administration because the response rate of the pilot test was improbable. The financial reward was drawn among the survey received using Excel. The winner was the one with the highest random number. This information was sent by email. Therefore, the data indicate a high relevance of the implementation procedure and the instrument content. The ethical decision-making approach was to establish roles and assuming the risk that a detailed explanation might distort the participant response. 10, academic management and students were informed of the objective, phase, and results of the research. Likewise, the ethical guidelines were followed, obtain informed consent during data collection, identify information in the data was separate from the participant's response to ensure the privacy was maintained. As a result, strict ethical criteria were certified free and responsible collaboration in the design, implementation, data collection, and data processing. The final administration of the questionnaire achieved a slightly higher response rate than the pilot test. The response rate was calculated in this equation. After the cleaning of duplicates, the number returned was 140 survey. However, although the survey was to send the total sample, 6 of them report that they had withdrawn from the training process and 1 email address bounce due to erroneous registration in the database. That is, this number was 280. Thus, the response rate was 53.21%. About the general function of the PCA dialogue system. The measure of central tendency and dispersion with frequencies and percentages about the student preference allow me to obtain generalization about the general function of the PCA dialogue system. Although there are no major difference in the response, it can be observed that in the data distribution, there are trends in the top 2 levels, agree and strongly agree. In this figure, participants agree that the PCA should encourage them to keep working, tell them what they do work, remember what they say, and give them good advice. That is, the PCA should offer motivation, identify error, remember the student dialogue, and give recommendation. Results also allow me to obtain generalization about the role and specific function of the PCA. Students indicate that the PCA should have the role of teacher-tutor, given that the other options were below, classmates, students, and other values. In addition, when they are not attentive to development orientation of the PIENSA, the PCA should attempt that it is going to contact the teaching staff, advise them to study more, and indicate that if they don't study, they will fail, instead of doing nothing. Likewise, when they don't understand the activity indication, the PCA should mainly explain in details all the steps to develop, because it was superior to the option of explanation them with one or more similar tasks, giving them hints, tips, and recommendations, repeating orientation as many times as necessary, and reserve questions about the activity. Thus, the results show a framework or specific function of the PCA dialogue system. About the qualitative analysis, content analysis of dialogue simulation was applied by transforming qualitative data into quantitative data. Dialogue simulation has 313 interventions, the student 159, and the PCA 154 times. The categories established were 6, which encompass the students and PCA dialogues. This show in the table 1 together with the quantitative results. The purpose was to evaluate them on an organized and systematized basis and make in-depth evaluation of their particularities. Results present some particularities. Some students' dialogue topic did not correspond to the same dialogue topic in the PCA response. It was since the entities modified the intention dialogue topic. An example can be seen in this figure. Additionally, some students demonstrate great knowledge, hence the PCA should be able to favor higher cognitive process. Likewise, it was characteristic that dialogue length was mostly short, both from the student and PCA, which may be for many reasons. In addition, repeatedly, it was possible to recognize implicit questions. However, these were not counted because they would create ambiguities. Finally, frequent errors were found in the writing. This situation increased when the dialogue length was greater. These particularities made it possible to analyze in depth the PCA dialogue system. Results integration allowed to obtain generalization and particularities of the algorithm of the PCA dialogue system. That is a response to research question. A certain point of convergence is the PCA role as teacher tutor. It should offer motivation and error identification, including writing error. Likewise, monoanalysis complement each other in several aspects. Request dialogue topic should be explained in details, and the PCA should recognize explicit and explicit questions. At the same time, it should remember dialogues and give recommendations. Furthermore, it will have to identify knowledge level if it is the case, favor higher cognitive process. It should correspond in dialogue length with that of the student, and if the student is not attentive, apply respective function. It is worth mentioning that no divergence data were found. Finally, in this figure, illustrates the initial algorithm of the PCA dialogue system. Which is based on the exposed meta-inference. About the conclusion, in this case, the most noteworthy aspects of the algorithm determination was to analyze the PCA dialogue flow for tutoring in the developed educational research project, since it allowed for the interpretation of the population perspective, both in generalities and particularities. The results indicate general and specific function and the role, that is pedagogical and social criteria of PCA. The research and co-design results in the algorithm of the PCA dialogue system should have the teacher-tutor role, offer emotional support, identify errors in the dialogue length, and so forth. What most support in the research was to unify, adapt, and validate the questionnaire because it addressed the mission to make up the variable. Also, there are several aspects of relevance and usefulness of the research results. The research linked to the PCA dialogue system with the Piensa tutoring, and the results were generated from an integrative and pragmatic approach with a mixed method. In addition, the study focused on the needs of the students and had a proposal of the algorithm for tutoring personalization, health support, and accompanying. Therefore, the study will allow teaching and engineer to have a solid context in the decision-making for the next phases of the design of the PCA dialogue system. Overall, the inquiry helped in the design of ICT-mediated dialogue learning applying tutoring and contribute to the adaptive learning in higher education. Acknowledging difficulties of encountered and thus partiality accomplished is scientifically ethical to provide solutions for future research. In the population and with the research procedure, the electronic survey is not the best alternative to have a higher response rate. Consequently, other administration ways need to be evaluated. In addition, data from the dialogue simulation are viewed to determine the student behavior. Hence, a broad database with diverse interaction is necessary to validate categories. Additionally, one of the gaps in the algorithm validation with the student is because they are part of the techno-pedagogical co-design. Accordingly, future studies should consider this task. All in all, the participation mechanism that guarantees the voice and vote of all, the big data, as well as the algorithm validation, are the weak points and shortcomings that allow to define the possible line of research continuity. In the next slide, you can see the reference of the research, and that's all. Thank you very much for your attention. In the case there are any questions, I encourage to intervene in this last session of the conference. Thank you very much.
Thank you, Elvis. I ask people if have any question for Elvis. I see one question. No, it's just a thank you for the presentation. I have just a quick question. It's just a curiosity about the technology you used for the building for this kind of personalized pedagogical conversational agent technology framework or what else. Oh, there is also another question from the room. I just read also the other question. It looks like the PCA is rule-based. Do you think the use of AI system to train the PCA could somehow improve the performance, accuracy, and quality of the response? There are two very connected, I think, questions about the technology you used and if you can improve this technology by integrating an artificial intelligence system.
Okay, in this context, in the UNAM, the students have many questions about the development of integration knowledge project, Piensa. Then the method of response, the question of the students will be many, for many. In this case, the roles is one many ways for attending this situation, and other ways is possible to respond to the question of the student. In this case, the research will be research and the student particularities and needs of the questions about the methodological or method of introduction of ways of attentive the piensa. In this case, the response is many ways for attentive the answer of the student.
Okay. Thank you for your answer and for your presentation.